Welcome back, guys, to Mathematical Mindset. Right here we have this nice Olympiad Algebra problem. So the question says the square root of 6 minus the square root of 6 plus x is equals to x. We have to solve for the value of x. So the first thing, guys, we want to do is to simply square both sides of the equation. So squaring both sides, we have this to be the square root of 6 minus the square root of 6 plus x all square is equal to x squared. So this is going to cancel out this. We have 6 minus the square root of 6 plus x is equal to x squared. So we want to simply rearrange this equation. So rearranging this, we have this to be 6 minus x squared is equal to the root of 6 plus x. So the next thing we want to do is to simply square both sides. So this becomes 6 minus x squared all squared is equal to the square root of 6 plus x all squared. So from here, we want to simply expand the left hand side of the equation. So applying this formula that says a minus b all square, this is equal to a square minus 2ab plus b square. So applying this to the left hand side, we have this equation to be, so we have 6 minus x square all square. This is equal to, we have 6 to be a and x squared to be b. So this becomes 6 squared minus 2 multiply 6 multiply x squared plus x squared all raised to the power of 2. So this is equal to 6 squared is 36 minus 2 multiply 6 is 12x squared plus x raised to the power of 2 multiply 2 is 4. So hence the equation becomes 36 minus 12x squared plus x4 raised to the power of 4 is equal to, now this is going to cancel out this, we have this to be 6 plus x. So from here we want to simply rearrange and set the equation to 0. So this becomes 36 minus 12x squared plus x raised to the power of 4 minus 6 minus x is equals to 0. So collecting like terms and rearranging this, so I'm going to bring out x raised to the power of 4 minus 12x squared minus x, so we have this to be plus 36 minus 6, which is equal to 0. So this becomes x raised to the power of 4 minus 12x squared minus x. 36 minus 6 is 30, so we have this to be plus 30, which is equal to 0. So we want to simply solve this by applying the rational root theorem. So we want to simply apply this theorem right here to solve this problem right here. So applying the rational root theorem, we want to simply find the possible rational roots of the constant term, which is 30. So the constant term 30, we have the rational root of 30 to be, we have 1 times 30, we also have 2 times 15, 3 times 10, 5 times 6, and so on. So from here we can add that the rational root have this to be plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, plus minus 15, and plus minus 30. So these are the possible roots for 30 right here. So we want to simply test the possible rational roots right here. So simply want to test the possible rational roots. So right here we're going to start from, we already know that any value we put in 1 is going to give us that same question. So 1 is asked from it, so we're going to test for x equals to plus 2. So we have the equation to be x raised to the power of 4 minus 12x squared minus x plus 30 is equals to 0. So let's see if x is equals to 2 is going to equal to 0. So from here we have 2 raised to the power of 4 minus 12 into 2 all squared minus 2 plus 30 is equals to 0. So from here we have 2 raised to the power of 4 is given as 16 minus 12, 2 squared is 4 minus 2 plus 30 is equals to 0. 16 minus 12 times 4 is 48 minus 2 plus 30 is equals to 0. 16 minus 48 minus 2 plus 30 is going to give us minus 4, which is equals to 0. So this is not equals to 0. So therefore, x equals to plus 2 is invalid. So we're going to test for x equals to minus 2. So testing for x equals to minus 2, we have this to be x raised to the power of 4 minus 12x squared minus x plus 30 is equals to 0. So for x equals to negative 2, this becomes negative 2 raised to the power of 4 minus 12 into negative 2 raised to the power of 2 minus into negative 2 plus 30 is equals to 0. So negative 2 raised to the power of 4 is 16 minus 12 into negative 2 square is 4. Minus times minus is plus 2 plus 30, which is equals to 0. So from here we have this to be 16 minus 12 times 4 is 48 plus 2 plus 30 is equals to 0. So 16 minus 48 plus 2 plus 30 is going to give us 0, which is equals to 0. So therefore we have x equals to minus 2 is a possible root. So we have this right here. So from this, in order for us to be able to factor out x raised to the power of 4 minus 12x squared minus x plus 30, we simply need to divide by the possible roots, and we can easily rewrite this possible roots to be x plus 2. So applying long division to solve this, so I'm just going to divide this by long division. So we have here to be x plus 2 divide x raised to the power of 4 minus 12x squared minus x plus 30. So let's simply divide this. So x divide x raised to the power of 4 will give us x raised to the power of 3. So this multiply x raised to the power of 3 multiply x will give us x raised to the power of 4. X raised to the power of 3 multiply plus 2 will give us plus 2x raised to the power of 3. So subtracting this from here, we have this to be negative 2x cubed. So we have this to be minus 12x squared minus x plus 30. So from here, we want to simply divide. So x divide negative 2x cubed is going to give us negative 2x squared. So negative 2x squared multiply x is going to give us negative 2x cubed. Negative 2x cubed multiply positive 2 will give us negative 4x squared. So subtracting this right here, we have this to be 12x squared minus 4x squared. It's going to give us negative 8x squared minus x plus 30. So x divide negative 8x squared will give us negative 8x. Negative 8x multiply x is negative 8x squared. Negative 8x multiplied 2 is going to give us negative 16x. So subtracting this right here, we have this to be 15x plus 30. Alright, so 15x divide x, we're going to have plus 15, and multiplying this with x plus 2, we're going to have 15x plus 30. So subtracting this, we have this to be 0 and 0. So hence, we have the quotient to be x cubed minus 2x squared minus 8x plus 15. So this becomes the new quotient, so we have been able to factor this out right here. So the next thing we want to do is to simply apply the rational roots theorem. So applying the rational roots theorem, we want to simply look for the possible rational roots of 15, and the possible rational roots of 15, we have this to be 1 times 15 and 3 times 5. So from here, we have this to be plus minus 1, plus minus 3, plus minus 5, and plus minus 15. So we're going to test the possible roots right here. So we're going to say for x equals to plus 3, we have this to be x cubed minus 2x squared minus 8x plus 15, which is equal to 0. Alright, so testing this, in place of x we put 3, so we have 3 raised to the power of 3 minus 2 into 3 all square minus 8 into 3 plus 15 is equal to 0. So from here we have that 3 raised to the power of 3 is 27 minus 2 into 3 square is 9 minus 8 multiplied 3 is 24 plus 15, which is equal to 0. So we have 27 minus 2 times 9 is 18 minus 24 plus 15 is equal to 0. So 27 minus 18 minus 24 plus 15 is going to give us 0, which is equal to 0. So therefore we have that x equals to plus 3 is a possible root. So we have this right here. So in order for us to be able to factor out the quotient, which is x cubed minus 2x squared minus 8x plus 15, we want to simply divide by the possible roots, and we can easily rewrite the possible roots to be x minus 3. So dividing this, making use of the long division, we have this to be x minus 3 into x raised to the power of 3 minus 2x squared minus 8x plus 15. Alright, so x divide x cubed will give us x squared. X squared multiply x is x cubed minus x squared multiply 3 is minus 3x squared. So subtracting this from here, we have this to be x squared minus 8x plus 15. So x divide x square, we have this to be plus x. X multiply x is x square. X multiply 3 is minus 3x. So subtracting this from here, we have this to be negative 5x plus 15. So x divide negative 5 here, so we are going to have negative 5. So negative 5 multiply x minus 3, we have negative 5x plus 15. And if we subtract this, we have this to be 0, 0. So hence, we have our quotient. So from here, we say that the quotient is given to us as x squared plus x minus 5. So we have been able to factor out the polynomial right there. So we can say the factorization of x raised to the power of 4 minus 12x squared minus x plus 30 equals to 0 is given as, we have this to be x plus 2, which is the first root. We have this to be x minus 3, which is the second root, and we have x squared plus x minus 5, which is equals to 0. Alright, so from here we have that x plus 2 is equals to 0. We have x minus 3 is equals to 0, and we have x squared plus x minus 5 is equals to 0. So from here we have that x is equals to 0 minus 2, and x is equals to minus 2. So I'm going to call this x1. So this is the first value of x. So from here we have x is equal to 0 plus 3, and x is equals to plus 3. So I'm going to call this x2. So we have the value for x2. So we say for x squared plus x minus 5 equals to 0, we are going to solve using the quadratic formula. So solve using the quadratic formula that states that x is equals to minus b plus minus the square root of b squared minus 4ac all into 2a. So from here we have that a is equals to 1, b is equals to 1, and c is equals to minus 5. So x is equals to minus 1 plus minus the square root of 1 square minus 4 multiply a, which is 1, multiply 5, which is negative 5, over 2 multiply 1. So x is equals to minus 1 plus minus the square root of 1 square is 1, minus 4 multiply 1 multiply negative 5 is going to give us plus 20 over 2 multiply 1 is 2. So x is equals to minus 1 plus minus the square root of 1 plus 20 is 21 over 2. From here, we have that x3 is equal to minus 1 plus the root of 21 over 2, and we have that x4 is equals to minus 1 minus the root of 21 over 2. So this becomes the value of x. So with this, guys, we have been able to solve this algebra problem here that says the square root of 6 minus the root of 6 plus 1 is equals to x. So from here, we can say that the first value of x is equals to minus 2. The second value of x is 3. The third value of x is given as minus 1 plus the root of 21 over 2. And the fourth value of x is given as negative 1 negative the root of 21 over 2. So this becomes the values of x.